Today let's look at probability of multiple events. So first of all, let's discuss what a dependent event is. It's when the outcome of one event affects the outcome of a second event. So then the independent event is when the outcome of one event does not affect the output of the second event. So if we want to look at and find the probability of A and B, if A and B are independent events, then the probability of A and B equals the probability of A times by the probability of B. So example, if the probability of A equals 1/2 and the probability of B equals 1/3, then the probability of A and B equals 1/2 times 1/3, which equals 1/6. So let's find the probability of rolling a number cube, then tossing a coin. We know those are independent because rolling a number cube will not affect what we will toss when we toss a coin. So if we pick a piece of fruit from a bowl and we eat it, then we pick another piece of fruit from the same bowl, that will be dependent because when we ate that last bowl, that affects the outcome of what we will pick out the second time, because we don't have the same amount of fruit anymore. So let's say you roll 2 dice and want to find the probability. So this is independent because when you roll 1 dice, it does not affect the roll of the second die. So we want to find the probability of 6 and 3. So the probability of rolling a 6 is 1 out of 6. The probability of rolling a 3 is 1 out of 6. So probability of 6 and 3 equals 1/6 times by 1/6, which equals 1 in 36. So what's the probability then of rolling an even and a 1? So probability of rolling an even, there's 3 evens, so it's 1/2. Probability of rolling a 1 is 1/6. So if we want to find the probability of both, we do 1/2 times 1/6, which equals 1/12. So now if we look at finding the probability of rolling a 7 and a 3, probability of rolling a 7 is 1 out of 6. Probability of rolling a 3 is 1 out of 6. So the probability of rolling a 7 and a 3 equals 1/6 times 1/6, which is 1/36. So A and B are independent events. We need to find the probability of A and B. So for this first one, probability of A is 3/8. Probability of B is 1/3. So we multiply the two. 3 times 1 is 3. 8 times 3 is 24. So it's the probability of 1/8 once we reduce 3/24. So let's find the last one. Probability of A is 3/8 times by the probability of B, which is 2/7. 3 times 2 is 6. 8 times 7 is 56. When we reduce it, the probability is 3 out of 28. Alright, a mutually exclusive event is when 2 events cannot happen at the same time. The probability of A or B, if A and B are mutually exclusive, meaning they don't happen at the same time, then we have the probability of A plus the probability of B. If A and B are not mutually exclusive, so meaning they do happen at the same time, then the probability of A or B equals the probability of A plus the probability of B, but then you're subtracting when they're the same. So let's look at some examples. We want to first identify, are they mutually exclusive, and explain why or why not. So rolling a 2 or a 3 on a number cube. These are mutually exclusive because you cannot roll a 2 or 3 at the same time. So rolling an even or a multiple of 3 on a number cube, that's not mutually exclusive because you can roll a 6, which is even, and it's also a multiple of 3. So these can happen at the same time. So what about rolling an even and rolling a prime number? That is mutually exclusive because you can't roll an even number or a prime number at the same time. So first let's identify whether these three are mutually exclusive or not. So 3 or an even, that's mutually exclusive because you can't roll a 3 or an even at the same time. An odd or a 5, this is not mutually exclusive because an odd 5 is an odd number. So all of our evens are 2, 4, 6, primes are 1, 3, and 5. So this is mutually exclusive. Alright, so let's take a look at the first one. So the probability of rolling a 3 is 1 out of 6, and probability of rolling an even is 3 out of 6, which is also equal to 1/2. So since it's mutually exclusive, we can add those two together. So I'm going to take my 1/6 plus my 3/6, which is 4 over 6. So reduce down to 2 over 3. Take a look at this next one. Probability of rolling an odd is 3 out of 6, whereas the probability of rolling a 5 is 1 out of 6. So if we add those two together, 3 over 6 plus 1 over 6, except we know we can also roll a 5 and an odd at the same time, and we have a chance of doing that one time, so we have to subtract 1/6, because that's what it's sharing. So 3 plus 1 is 4 over 6 minus that 1/6, end up with 3 over 6, which is 1/2. So let's look at this last one we'll do together. So the probability of rolling an even equals 3 over 6. The probability of rolling a prime number is 3 over 6, and we know it's not mutually exclusive because we can't roll an even. Oh, sorry. 2 is also a prime number, so it's 4 out of 6. So when we add, so the probability of an even or a prime, so this is not mutually exclusive, is 3/6 plus our 4/6 minus the 2 is being shared, so minus that 1/6 that they share. So 3 plus 4 is 7/6 minus that 1/6, so 6/6, so it is 1, so it's 100% probability of rolling an even or a prime. So J and K are mutually exclusive events. We want to find P, the probability of J or K. So the probability of J is 3/5, the probability of K is 1/3, so in order to add them, they have to have common denominators. So if I multiply both the numerator and the denominator by 3, and then this one by 5, we end up with 9/15 plus 5/15. So we have probability of 4/15. So for this one, probability of J is 1/7. The probability of K is 60%, which is really 60 over 100. So reduce down to 3/5. So the common denominators, we multiply the numerator and the denominator both by 5. Multiply the numerator and the denominator by both by 7. So we end up with 5 over 35 plus 21 over 35. So when we add these two, we get 26 over 35.